Adaptive cruise control warning lights are your vehicle's way of communicating system status and potential issues. Understanding these signals is crucial for maintaining safe driving conditions. There are two main types of ACC warning indicators. A solid warning light indicates serious issues like complete system shutdown, critical sensor malfunction, software corruption, or power supply problems. A flashing warning light typically indicates less severe but still important issues. These include temporary sensor obstruction, calibration drift, environmental interference, or partial system functionality. Environmental factors are the most common cause of ACC warnings, accounting for about 40% of all issues. Heavy rain, snow, fog, and extreme temperatures can all interfere with sensor operation. The solution for environmental issues is often straightforward. Clean sensors with appropriate cleaning solutions, allow warm-up time in extreme cold, and use sun visors or covered parking to reduce glare and exposure. Sensor calibration issues account for 35% of ACC warnings. These often occur after windshield replacement, minor collisions, or software updates that affect sensor alignment. Calibration solutions include static calibration using alignment targets or dynamic calibration through specific driving patterns. Professional ADAS calibration typically costs between $150 and $400. Electrical problems cause 15% of ACC warnings and include weak battery voltage below 11.5 volts, corroded connections, or blown fuses in the ACC circuit. Software glitches account for 10% of issues, including corrupted firmware, incomplete updates, or memory allocation errors. These can often be resolved through hard reset procedures or reflashing the ECU software. Understanding these warning light patterns and their common causes helps you take appropriate action quickly. In the next section, we'll cover specific reset procedures you can perform to restore your AC system functionality. There are several effective methods to reset your ACC system when warning lights appear. We'll cover three main approaches, starting with the most basic method. The basic reset method involves disconnecting your vehicle's battery. This simple procedure clears temporary system errors and resets the ACC control module. First, turn off your engine and remove the key. Then, disconnect the negative battery terminal for exactly 15 minutes. This allows the system to fully discharge and reset. For more reliable results, use an advanced reset with an OBD2 scanner that has ADAS capabilities. This method provides direct access to the ACC system's diagnostic functions. Connect your OBD scanner, navigate to the ACC system menu, clear any fault codes, and perform the sensor initialization sequence. Complete the process with a calibration drive cycle. Different manufacturers have specific reset procedures. Toyota and Lexus vehicles require holding the cruise control button while performing steering wheel movements and a specific drive cycle. Honda and Acura vehicles use a different approach. Press and hold both the main and set buttons simultaneously, cycle the ignition 3 times, then complete a 15-minute highway drive. BMW and Mercedes vehicles require proprietary diagnostic software like ISTA Plus or Zentry. These professional tools perform sensor teaching procedures and validate the system through road testing. Modern vehicles now feature enhanced diagnostic capabilities, including over-the-air updates and advanced OBD3 integration. These systems can often resolve ACC calibration issues remotely without requiring a dealership visit. Choose the reset method that matches your vehicle and available tools. Start with the basic battery reset for simple issues. Use OBD scanners for more reliable results, or consult professionals for manufacturer-specific procedures.